Today we're going to be learning all about electricity and how does it work and all the components of electricity. Electricity is a form of energy resulting from the movement of charged particles, primarily electrons, through the conductive material. It's a fundamental force of nature and is essential to powering modern technology, from household appliances to industrial machines. Let's break down electricity into various concepts and delve into its history, types, and applications. Basic concepts of electricity. Charge. Electricity is based on the perspective, presence, and movement of electric charge. There are two types of electric charge, positive and negative. Like charges repel and the opposite charges attract, the fundamental carrier of electric charge in most materials is the electron. Current I. Electric current is the flow of electric charge through a conductor, typically measured in amperes. There are two types: direct current DC, also known as DC, the flow of electric charge in one direction, commonly used in batteries. Alternating current, AC, the flow of electric charge that reverses direction periodically, which is used in most electrical power systems. So basically, conductor is like it's a material where electricity can flow through. Um, so for example, one conductor of electricity can be metal. Electricity can flow through metal. For example, we can say like a TV or something. Most modern technology, and or one non-conductible uh, resource. Uh, uh, Resource could be, for example, like wood. Yeah. So wood is non-conductible because electricity cannot flow through. Voltage. Voltage is the difference in electric potential between 2 points in a circuit driving the flow of current. It's measured in volts. V. Resistance. Resistance is the opposition that a substance offers to the flow of electric current, measured in ohms. Materials with low resistance, such as copper, are good conductors, while those with high resistance, like rubber or insulators. Power P. Electrical power is the rate at which electrical energy is consumed or produced, typically measured in watts. Types of electricity. Basically these are the three types of electricity. One of them is the first one is static electricity. Static electricity refers to the accumulation of charge on an object, typically caused by friction. This can lead to phenomena such as a spark or lightning where accumulated charge is discharged. For example, we can test static electricity by rubbing a balloon on the head. So basically, you have to rub the balloon on the head, and then when you when you pick it up and put it a bit high, the hair is gonna stick to the balloon for a while. Current electricity. This is the type that flows through conductors. This can be DC or AC and used to power electrical devices. So basically, this is trying to say current electricity is basically electricity which can flow through. Unlike in static electricity, electricity does not flow. It gets created because of friction or something. Uh, Unlike that, current electricity is electricity which is not made naturally, which can flow through. like conductors, as the slide before. Electromagnetism, a related concept where electrical currents generate magnetic fields. This principle is used in motors, generators, and transformers. Sources of battery electricity. Batteries store chemical energy and convert it into electrical energy through chemical reactions, common in portable electronics. So basically, those batteries we put in cars or sometimes MP3 players and stuff. Those, those, um, sometimes in a clock or something, when the cell is not used for a long time, explodes and some brown gooey chemical comes out, right? That is called that is called electric that is called chemical electricity energy. When that liquid stores energy inside, and the cell converts it to electrical energy, which can flow through chemical reactions. It's mostly common in portable electronics, as I said, like in cars or stuff. Power plants generate electricity on a large scale. They can run on various energy sources: thermal, fossil fuels, coal, oil, or natural gas. Nuclear. Nuclear fission produces heat to drive turbines. Renewable. Wind, solar, hydroelectric, or and thermal, geothermal power plants generate electricity without depleting natural resources. Conductors, insulators, and semiconductors. Conductors materials that allow electricity to flow easily due to the low resistance, as I said in the slides before. Common conductors include metals like copper, aluminium, and gold. Insulators, materials that resist the flow of electricity. Rubber, plastic, and glass are common insulators which electricity cannot flow through. Semiconductors, materials whose electrical properties lie between conductors and insulators. Silicon is the primary material used in modern electronics such as computers and smartphones. Circuitry and electrical components. Electricity typically flows through a closed loop or circuit. Components of electrical circuits include resistors, limit the flow of electrical current; capacitors store and release electrical energy; inductors store energy in magnetic fields when current flows through them; diodes allow current flow in only one direction, crucial for controlling the flow of electricity; and transistors act as switches or amplifiers in modern electronics. These are a list of some units of measurement used in electricity and volt. V, also known as V, unit of electrical potential voltage. Ampere, ampere, also known as A, unit of electrical current. Ohm, also known as a sign provided, is the unit of electrical resistance. Watt, also known as W, unit of electrical power. Joule, J, unit of electricity equivalent to the work done when 1 ampere flows through a resistance of 1 ohm for 1 second. Applicators of electricity: residential, powering lights, appliances, heating and cooling systems; industrial, machinery, factory automation, and heavy equipment rely on electrical energy. Electronics or computers, smartphones, and communication devices depend on the precise control of electricity through circuits. So these are like normal everyday devices we use. Transportation, electric vehicles, trains, and mass transit systems use electricity for propulsion. So these type of uh, vehicles, you can use electricity to keep it on moving and to help us transport around the city or country. Medical equipment such as MRIs, pacemakers, and defibrillators rely on electrical power. So, like all the medical things we use, all of these are used and charged by electricity. Communications. Electricity involves telecommunication systems, including telephones, internet, and broadcasting, like we're doing right now in YouTube. Electricity generation and distribution. Power grids. Large scale networks that generate, transmit, and distribute electricity from power plants to homes and businesses. A typical grid includes transmission lines, high voltage carry electricity over long distances. Transformers step up or step down voltage to optimize transmission. Distribution lines deliver electricity to local users at lower voltages. Safety and hazards. Electricity can be dangerous if not handled properly. Common electrical hazards include electric shock, like when I touch a broken plug, which is plugged in and powered on, I could get a shock. Uh, Short circuits. That's the one of the main ones. That's one of the main ones. We should also always be really careful of that. A fault where current bypasses normal paths leading to overheating or fire. Electrical fires. That's also one of the main ones. Arise from overloaded circuits, faulty wiring, malfunctioning electrical equipment. Environment impact. Fossil fuel based power. Traditional electricity generation from coal, natural gas, and oil contributes to pollution and climate change. Renewable energy. Wind, solar, and hydropower produce electricity with little or to no carbon emissions. Energy efficiency. Advances in energy efficient technology help reduce electricity consumption and the environment impact of power generation. Electricity, the conclusion. Electricity is an integral part of modern society, powering everything from household devices to industrial machinery. Its discovery and harnessing have driven technological process, making life more convenient, productive, and connected. For example, um, back in my country, my grandma lives there, so every day I call her by phone, and that's because of that we still stay connected. However, managing electricity safely and efficiently while minimizing its environmental impact is one of the critical challenges of the modern world. Thanks for listening. Please subscribe, and if you have any questions, please write it down in the comments below. Today was a long video, right? I hope you enjoy. And so sorry, we're still fixing our site, which has been unfortunately broken, which has been unfortunately which we have accidentally deleted the site. So our team is trying our best to make it as quick as we can. Thank you for listening. Bye bye.